Hello everyone, I am Maria Patricia Barayoga from Tribe 3. So in this video, I will discuss about measure of relative position, especially standard deviation or Z-score. This video will contain the definition of Z-score, the given, and how to solve the Z-score. So please be quiet and listen carefully. Standard deviation or Z-score. A Z-score describes the position of a row. Score in terms of this distance from the mean. When measured in standard deviation units, the Z-score is positive if the value lies above the mean, and it negatives if it lies below the mean. It is also known as standard score because it allows comparison of scores on different kinds of variables by standardizing the distribution. A standard normal distribution, or SND, is normal shape with distribution with a mean of O and standard deviation, or ST, of I. Using this formula, Z is equal score minus mean over standard deviation. As the formula shows, the Z-score is simply the raw score minus the population mean divided by the population standard deviation. When the population mean and the population standard deviation are unknown, the standard score may be calculated using the sample mean for X and the sample standard deviation for S as estimated of population values. Here the example. Let us take the example of a class of 50 who had written the math test last week. Today is the result day. And the class teacher told me that Tyler scored 93 in the test while the average of score of the class was 68. Determine the Z-score for Tyler test mark if the standard deviation is 13. Solution given. Tyler test score X equals 93. The mean U equals 68. The standard deviation Q equals 93. Therefore, the Z-score for Tyler test score can be calculated using the above formulas as C, Z equals X minus U over standard deviation. Z equals 93 minus 68 equals 25 over standard deviation 13. After that, we need to divide 25 divide 13 equals 1.92. So the Z-score equals 1.92. Therefore, Tyler test score is 1.92, standard deviation above the average scores of the class, which means 49 students score less than Tyler. That's all, and hoping that everyone understands the Z-score. Thank you for watching.
So, we come now to the percentiles. The percentiles is one way of assessing performance is by the use of percent. The percentiles are the score points that divide a distribution into 100 equal parts. So, for example, the 10th percentile, or P10, separates the lowest 10% from the 90%. Another, the 25th percentile, or P25, separates the lowest 25% from the other 75%, while the 80th percentile, or P80, separates the lowest 80% from the other 20%. So, mapapansin nyo, lahat sila equal sa 100%. Consider the situation. If Juan got a score of 60 and ranked 9th in a class of 150 students, it means that 150 student minus 9 kasi ika-9th si Juan sa class nila is equal to 141 students. Then, yung 141 student na yon, ito yung student na below his rank, mas mababa pa sa kanya. So, if we get the percentage, 141 students divided by 150 students is equal to 0.94 or 94%. It means that itong 94% na to, ito yung class rank below or got scores below than Juan. Then we can say that the percentile rank of Juan in the class is 94, which also implies that 94 out of 100 students got scores below his scores. Mas mababa pa sa nakuha ni Juan. And the 5% of the class ay nakakuha naman ng mas mataas pa kay Juan. So, the percentile rank tells how many percent of the cases got below the rank or position. So, di ba kanina, Juan get a score of 60. So, we can say that the 94th percentile points is 60. Ang percentile point naman ay it is the score or value that corresponds to the given percentile rank. So, it is denoted by the symbol Pn, where n is the percentile rank. Thus, in the example, P94 is equal to 60. Diba si Juan get a score of 60. So, itong 60 na ito yung percentile point niya. Then, kaya naman 94, ang percentile rank niya, which is itong kulay green, ito yung na-compute natin kanina doon sa 141 divided by 150 is equal to 0.94 or 90%, kung saan nagpapakita ito na si Juan ay ika-94th rank out of 100 student dahil doon sa nakuha niyang score, which is 60. How to solve the percentile for ungrouped data? So, di ba, sabi ko kanina, percentiles divide data into 100 equal parts. So, this is the formula for finding the percentile, where I is 1 to 99, that is percentile 1 to percentile 99, and the n is the number of samples. So, let's come now to the example number 1. Find the percentile 40 of the following set of data. So, the first thing we need to do is to arrange the data into ascending order. Now, this is the formula for finding the percentile 40. So, Ri is equal to 40. So, that is now 40 times 15 number of samples plus 1 over 100. So, 15 plus 1 is equal to 16 times 40 is equal now to 640 divided by 100. So, 640 divided by 100 is equal to 6.4. So, 6.4 is between to the 6th and 7th data. Kasi kung bibilangin nyo, di ba? 1, 2, 3, 4, 5, 6. Yung 8, ika-6 siya, and then yung 9, ika-7. So, between to 6 and 7 siya. So, the percentile of 40 is equal to the 6th data plus 0.4 times the difference of the 7th and 6th data. So, the 6th data is 8 kasi 8 yung ika-6 doon sa data plus 0.4 times the 7th data, which is yung 9, and the 6th data, which is yung 8. So, 9 minus 8 times 0.4 plus 8 is 8.4. So, let's have this example number 2. Let us find the percentile 50. Now, again, do not forget to arrange the data in ascending order. So, this is the formula for finding the percentile 50. So, since we are looking for the percentile 50, meaning Ri is 50. So, that it's now percentile 50 is equal to 50 times 15 number of samples plus 1 over 100. So, 15 plus 1 is 16 times 50, that is now 800 divided by 100. So, percentile 50 is the 8th data. So, let us count 1, 2, 3, 4, 5, 6, 7, 8. So the 8th data is 10. Therefore, the percentile 50 is 10. So let's have another example. Let us find the percentile 75. So again, do not forget to arrange the data into ascending order. This is the formula. So we are looking for P75, Ri is 75. Now we have percentile 75 is equal to 75 times 15, number of sample, plus 1 over 100. So 15 plus 1 is 16, times 75 is 1,200 over 100. So 1,200 divided by 100 is 12. So meaning the percentile 75 is the 12th data. So what is the 12th data? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12th data is 14. Therefore, the percentile 75 is 14. So, how to calculate the percentile for group data using this formula, where the n is the total frequency, less than Cf sub b is the cumulative frequency before the percentile class, Fpk is the frequency of the percentile class, Lb is the lower class boundary of the percentile class, and I is the class width of the interval. So, let's compute the missing part of the cumulative frequency distribution. So, first, let's find the value of the class width or the interval. We can find this by counting the over limit up to the higher limit. Let's start at 11 to 20. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the class width or the interval is equal to 10. After that, let's get the value of n or the frequency by getting the summation of all the numbers in the column of frequency. So, i-add natin lahat ng numbers sa frequency. 5 plus 6 is equal to 11. 11 plus 7 is equal to 18. So, 18 plus 10 is equal to 28. And 28 plus 2 is equal to 30. So, the class width or the frequency is 30. Next one is the lower boundary. So, we can get the lower boundary by subtracting the lower limit by 0.5. So, 51 minus 0.5 will be equal to 50.5. And 41 minus 0.5 will be equal to 40.5. Then, 31 minus 0.5 will be 30.5. 21 minus 0.5 is equal to 20.5. And 11 minus 0.5 is equal to 10.5. The next one is the less than cumulative frequency. So, para makuha natin tong less than cumulative frequency, tingnan natin yung first class, which is, ito yung 11 and 20. Itong 11 and 20 na to, ang frequency nila ay 2. Then, itong 2 na to, ikakopy natin to dito sa less than cumulative frequency. Pag nailagay na natin yung 2 doon sa less than CF, after that, i-add natin itong 2 na to doon sa sunod na frequency, which is ito yung 10. So, 10 plus 2 will be equal to 12. Then, itong 12 na to, ilalagay natin siya dito sa less than cumulative frequency. Then, 12 plus 7 will be equal to 19. So, 19 plus 6, kasi ito yung pang fourth frequency, will be equal to 25. Then 25 plus 5 will be equal to 30. So, dapat equal ng value itong less than cumulative frequency doon sa total frequency, which is equal to 30. Now, after we have complete the cumulative frequency distribution table, let's try to compute the value of percentile 57. So, first step we need to do is to get the percentile class by using this formula. So, k times n all over 100. We will substitute the value of k, which is equal to 57, and the value of n is equal to 30, then over 100. Since we are looking for percentile class, so that will be over 100. We will simplify 57 times 30 and divide the answer by 100. It will be equal to 17.1. Now, to get the percentile class, tingnan natin itong less than cumulative frequency table. So, dapat itong less than cumulative frequency must be greater than or equal to 17. So, itong 2, less than ito sa 17.1. So, hindi ito yung percentile class. Then, ito naman 12, hindi din siya yung percentile class. So, itong 19, ito yung greater than 17.1. Therefore, our percentile class is located at third class. Kasi itong 2, yung sa baba, yun yung first class. Then, itong 12 naman, ito yung second class. Then, itong third class, ito yung 19. After that, we will now be using the formula of percentile for the group data. We have the percentile k is equal to lower boundary plus the quantity of k times n all over 100 minus less than cumulative frequency before the percentile class all over the frequency of the percentile class times the class width or the interval. We will be substituting the corresponding value. So this will be the percentile 57 is equal to the value of the LB or lower boundary since the percentile class is on the third class, which is ito yung 30.5. Then 30.5 plus the quantity of k times n all over 100, which is yung kn, ito yung 17.1 kasi ito yung na-compute natin kanina. So, k times n all over 100 is equal to 17.1. 17.1 minus the less than of cumulative frequency or less than CFB, itong B, ibig sabihin ito before. Ibig sabihin, ang kukunin natin is yung sa baba ng 19. Kasi 'di ba yung 19, ito yung percentile class natin. So, before, which is ito yung sa baba, itong 12. Then, 12 all over the frequency of the percentile class, which is yung 7 kasi ika-third class siya doon sa frequency column, times the class width or the interval, which is yung 10. Then, we will be signifying this. So, bring down the percentile 57, then bring down also the 30.5 or the LB plus 17.1 minus 12 is equal to 5.1. Then, divided by 7. And then, multiply them by 10. Then, the answer will be equal to 7.29. So, 30.5 plus 7.29 will be equal to 37.29. So, if we will interpret this, 57% of the total frequency has a score of which is less than or equal to 37.29. Let's have another example. Let's calculate the percentile 13. So, we will be identifying the percentile class using the formula k times n divided by 100. So, substitute the corresponding value. So, we have the value of k is equal to 13 and the value of n is equal to 30 divided by 100. So 13 times 30 divided by 100 is equal to 3.9. Now, we will look at our less than CF or cumulative frequency column. So 2 is less than 3.9. So this will be not the percentile class. Then 12 is greater than 3.9. So this will be our percentile class. This row, the second class. After that, we will now be using the formula of percentile for the group data. We have the percentile k is equal to lower boundary plus the quantity of k times n all over 100 minus less than cumulative frequency before the percentile class all over the frequency of the percentile class times the class width or the interval. Then, substitute the corresponding value. So, the percentile 13 is equal to the value of LB or lower boundary, which is 20.5 plus the quantity of the value of K times N all over 100 has already been computed, which is equal to 3.9 minus the less than cumulative frequency or CF which is 2 kasi before siya ng percentile class natin na 12. All over the percentile class which is 10 kasi itong 10 doon sa second row natin sa column ng frequency times the interval or class width which is 10. Then we will be simplifying this. Bring down the percentile 13. Bring down also the LB or the lower boundary which is 20.5. Then 3.9 minus 2 is equal to 1.9. Then 1.9 divided by 10 times 10 is equal to 1.9. Then add these two numbers. 20.5 plus 1.9 is equal to 22.4. Then percentile 13 is equal to 22.4. If we will interpret this, 13% of the total frequency has a score of which is less than or equal 22.4. I'm Eliza Micaela B. Orada from Tribe 3 and I hope you learned something. Thank you!
So hi everyone, my name is Justin Parang. So for today, I will discuss quartile. And first, what is quartile? In statistics, a quartile is a type of quantity which divided the number of data points into 4 parts or quarters or more or less equal size. The data must be ordered from smallest to largest to compute quartiles. As such, quartiles are form of order in statistics. So let's talk about quartile in a group of data. Quartiles divide a ranked order data set into 4 equal parts. This is the formula of finding quartiles, where I is equal to 1, 2, 3, and n is the number of samples. So let's have this example number 1. Let's have find quartile 1, quartile 2, and quartile 3 of the following set of data. So let's start with quartile 1. First thing need to do is to arrange the data in ascending part. So since we are finding quartile 1, our I is 1. So that is now use of 1 is equal to 1 times our n is 15. So we have 15 is the sample numbers here plus 1 over 4. So that is now 16 over 4. So 16 divided by 4 is 4. So meaning the quartile 1 is the fourth data. So we're going to count 1, 2, 3, 4, and 6. So therefore the quartile 1 is 6. So So let us now find quartile 2. So let's now find the quartile 2. Again, arrange the data in descending order. So our I now is 2. So it's now use of 2 is equal to 2 times again we have 15 numbers of samples plus 1 over 4. 15 plus 1 is 16 times 2, that is 32 over 4. 32 over 4 is 8. So meaning quartile 2 is the 8th data. So the 8th data is from 1, 2, 3, 4, 5, 6, 7, 8. So it will be 10. So therefore our quartile 2 is 10. So let's now find quartile 3. So again, arrange the data first. So this time, our I is 3. So we have use of 3 is equal to 3 times. So we have 15 numbers of samples plus 1. So 15 plus 1 times 3. So that is 48 over 4. So 48 over 4 is 12. So quartile 3 is the 12 data. So 12 data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12 data is 14. So therefore, quartile 3 is equal to 14. So when Q1 and Q2 are not integers, the quartile are about interpolation. So that's all about quartile. Thank you everyone.
When it comes to visualizing a summary of a large data in 5 numbers, many real-world box and whisker plot examples can show you how to solve box plots. As many other graphs and diagrams in statistics, box and whisker plot is widely used for solving data problems. Believe it or not, interpreting and reading box plots can be a piece of cake.
Now, let's define it. A box and whisker plot, also known as a box plot, is a graph that represents visually data from a 5-number summary. These numbers are median, upper and lower quartile, minimum and maximum data value. Don't panic, these numbers are easy to understand. Look at the following example of box and whisker plot. So there are a couple of things you should know in order to work with box plots. The lower extreme, the smallest value in a given dataset. Upper extreme, the highest value in a given dataset. Median value, the middle number in the set. Lower quartile, below that value, the lower 25% of the data are contained. Upper quartile, above that value, the upper 25% of the data are contained. Whiskers, the lines that extend from the boxes. They are used to indicate variability out of the upper and lower quartiles. To put it in another way, we have 3 key points. The first is the middle point. This is the median. The others are the middle points of the 2 halves. These 3 points divide the dataset into quarters that we call quartiles. A quartile is a type of quantile in statistics that divides the number of data points into 4 parts or quarters of roughly equal size. To compute quartiles, the data must be ordered from smallest to largest, thus quartiles are a type of ordered statistic. We will make the things clearer with a simple real-world example. It also illustrates the steps for solving a box and whisker plot problem. For example number 1, a simple box and whisker plot. Suppose you have the math test results for a class of 15 students. Here are the results: 91, 95, 54, 69, 80, 85, 88, 73, 71, 70, 66, 90, 86, 84, and 73. It is hard to say what is the middle point, the median, because the value points are not ordered. Step 1. Order the data points from least to greatest. Step 2. Find the median of the data. This is an odd set of data. You have 15 data points. It means the middle point is 80 as there are 7 data points above it and 7 numbers below. Step 3. Find the middle points of the 2 halves divided by the median. Find the upper and lower quartiles. Step 4. Find the extreme values. This is the easiest part. You need to find the largest and smallest data values. Extreme values is 54 and 95. So, we can determine that the 5-number summary of the class of students is 54, 70, 80, 88, and 95. Now, we are absolutely ready to draw our box and whisker plot. As you see, the plot is divided into 4 groups: a lower whisker, a lower box half, an upper box half, and an upper whisker. Each of those groups shows 25% of the data because we have an equal amount of data in each group. The box and whisker plot shows that 50% of the students have scores between 70 and 88 points. In addition, 75% scored lower than 88 points, and 50% have test results above 80. So if you have test results somewhere in the lower whisker, you may need to study more. It was among the simplest box and whisker plot example just to illustrate what the plot shows. Let's dip further and see double box and whisker plot examples that help you to compare two data sets. For example number 2, comparative double box and whisker plot. Suppose an IT company has 2 stores that sell computers. The company recorded the number of sales each store made each month. In the past 12 months, we have the following numbers of sold computers. The store 1 has 350, 460, 20, 160, 580, 250, 210, 120, 200, 510, 219, and 380. Store 2 has 520, 180, 260, 380, 80, 500, 630, 420, 210, 70, 440, and 140. In order to compare the 2 store sales performance, we will make 2 box and whisker plots, one for store 1 and one for store 2. In the store 1, first we put the data points in ascending order: 20, 120, 160, 200, 210, 250, 290, 350, 380, 460, 510, and 580. Now, we need to find the median. However, this is an even set of data. There isn't only one middle point. The middle in our case belongs to 6 plus 7 data points. Example, 250 and 290. And for the formula for the median in an even data set is the sum of the 2 middle numbers divided by 2. The median is 250 plus 290 divided by 2 is equals to 270. Now, let's see what happens with the lower and upper quartile in an even data set. There are 6 numbers below the median, namely 20, 120, 160, 200, 210, 250. Lower quartile is the median of these 6 items, so 3rd plus 4th data point divided by 2. This is 160 plus 200 divided by 2 is equals to 180. There are also 6 numbers above the median, namely 290, 250, 280, 460, 510, and 580. Upper quartile is the median of these 6 data points. 3rd plus 4th data points divided by 2 equals 420. Finally, the number 5 summary for store 1 sales is 20, 180, 270, 420, and 580. Using the same calculations, we can find that the 5-number summary for store 2 is 70, 160, 320, 470, and 630. Now, we are ready to draw our comparative double box and whisker plot example. Store 2's highest and lowest sales are both higher than Store 1's relevant sales. In addition, Store 2's median sales value is higher than Store 1's. Also, Store 2's interquartile range is larger. These results tells us that Store 2 consistently sells more computers than Store 1. Nowadays, you have plenty of good choices. Depending on your needs, you can create them with a free graphing software such as Plot.ly, MetaChart.com, or you can use powerful premium software such as W. Of course, you can draw them with Microsoft products such as Word, Excel, PowerPoint. Finally, just use a sheet of paper or a whiteboard to draw your box plot. The above box and whisker plot examples aim to help you understand better how to solve them. Box plots are among the most used types of graphs in the business, statistics, and data analysis. It is especially useful when you want to see if a distribution is skewed and whether there are potential unusual data values in a given data set. These plots are also widely used for comparing two data sets. A box plot is a great way of summarizing data set of measured on an interval scales. It has many advantages and benefits, and the most important of them are able to handle and present a large amount of data, a visually effective method of viewing a summary, a graphical way showing outliers, great for comparison of two or more datasets. And that is the box and whisker plot. This is Riza Ami available.